Welcome. So in this course, we're going to be learning about computer architecture. And this course is an adaptation of a course which I teach at Princeton University called ELE, or for Electrical Engineering 475. And I'm David Wensloff. I'm a professor here at Princeton. And my background is mostly looking at how to build many-core and multi-core microprocessors. And in the past, I've actually built two of the world's fastest many-core microprocessors in industry. And before that, I've worked in academia building many-core microprocessors. So about 15 years of processor design experience. In today's lecture, we're going to be talking about an introduction or some opening to what is computer architecture, why do you want to learn computer architecture, how it's different than previous courses that you might have taken, so something like a computer organization class or a logic design course. And then we'll talk about some content today, which is looking at instruction set architectures and how a instruction set architecture or big A architecture is different than implementation or microarchitecture, and why it's a good idea to split out these two ideas. So let's take a step back and look at the course administration of this class and how this class is going to be organized. So as I said, I'm David Wensloff. This class is roughly going to be the equivalent of 2 80-minute lectures a week. So this is the same format that's used at Princeton University for this course. And we're going to try to segment it into shorter segments to sort of give you bite-sized nuggets with questions and answers intermixed to check your understanding as the video goes on. Two books that I wanted to talk about. This is the Computer Architecture, A Quantitative Approach by John Hennessy and David Patterson. This is a very, very good book. If you are going to be doing computer architecture, I highly recommend it. And it's a heavily, heavily, heavily suggested book for this course. I did want to point out that there's a lot of different versions of this book floating around. We're going to be using the 5th edition, and you should go get the 5th edition. The 5th edition is very different than the 4th edition. It's updated as of 2012, so it's very fresh. And then a auxiliary text, which is useful for a portion of this class. I'll mention it as the Shen-Leposti book, because of the two authors. Modern Processor Design and Fundamentals of Superscalar Processors. The reason we're going to use this book, or a reason that we're going to, I'll recommend some readings out of this book, is that it has a lot deeper coverage of superscalar processors than the computer architecture book. So this is a great book to begin with, but it doesn't cover how to build superscalar processors in great depth. This book goes on to do that, and that's something we're going to be talking a lot about in this course. A lot of the content of computer organization, or a traditional computer organization class, I'm going to repeat in the first 3 lectures of this course, or the first 3.5 lectures of this course. And the reason for this is because I teach everything from first principles and want to get everyone on the same page, but we're going to go very, very fast through that material. So if you've not had a computer organization class, it may be possible to take this class, but I highly recommend taking a computer organization class before this class, because this is the second class in sort of a computer architecture series where you'd have computer organization and computer architecture, and we really do rely on the prereqs. But if you are watching the first 3 lectures and you say, I know all this, yes, that is correct. You should know all this. If you don't know all this, then you should probably go back and retake computer organization or take a computer organization class. But don't drop the class if you take the first 3 lectures and say, oh, I know all this, and just leave at that point. Because we're just going to breeze through that content very fast as building from first principles.